Okay, so number 7, or number 1, on problem set 2, part 2, asks us, 2 equal parallel chords are drawn 6 inches apart in a circle of radius 6 inches. Find the area of that part of the circle that lies between the chords. So I've gone ahead and drawn us a circle with 2 equal parallel chords up here on the whiteboard. Now, it asks us to find the area that's between them. My first inclination, I'm going to go ahead and draw a rectangle here. Because in order to find this area, the length or the height of these chords is going to be useful. So I know that they're 6 inches apart. And because the diameter is 6, or the radius is 6, the diameter is 12. So if I draw a line through the circle, touching with both ends on the circle, through the center with both ends on the circle, it'll have length 12. This is a right angle. We just formed a rectangle there, right? So now we have x squared plus 6 squared, 36, equals 12 squared, 144. So now x squared equals 108. So x equals the square root of 108, which if you simplify, x equals 2 times the square root of 27. So let's not call it x anymore, let's call it 2 root 27. Now while we're here, I'm going to go ahead and find this angle's measure. We're going to call that theta. And we're going to use the sine rule to find that angle's measure. So I'll separate that. So we have the sine of theta divided by the side that's opposite of it, 6, is equal to the sine of pi over 2, or 90 degrees, divided by the side that's opposite, 12. So the sine of theta, sine of pi over 2 is 1. It's going to be 6 times 1 over 12. That's just going to get me 1/2. So theta must be pi over 6, or 30 degrees. Let's go ahead and enter that in. So it's pi over 6, or 30 degrees. Now, I'm never going to be able to find the area between the 2 chords with a rectangle. So I'm always going to have this top and this bottom. And I'm never going to be able to figure that area out unless I get rid of the top and bottom, so I no longer have a rectangle, and I draw another diameter through the circle such that all of these sides are the same. They're all the radius, so they're all 6. And now I've got 2 equal sectors and 2 congruent triangles. So, in order to find the area of the sectors, I'm going to need the angle that's right here. Because the formula relies as 1/2 theta times r squared. So we know the radius, but not the angle. Well, if these two are congruent, then this angle is also pi over 6. And I can use the fact that a triangle has pi radians in it, or 180 degrees. So I can say this angle is z. So z plus 2 times pi over 6 equals pi. Z plus a pi over 3 is pi. Z is 2 pi over 3. So that's this angle here. This angle is 2 pi over 3. Well, these form a linear pair, so this one's going to be pi over 3. So now I can find the area of the sector. And how about the area of the triangle? 1/2 theta times height. Well, we're told that these are 6 units apart, split evenly, so the height of both must be 3. Now I can do a little bit of work. The area of the triangles is going to equal 2 times 1/2 base, 2 root 27, times the height of 3. So that's just going to get me 6 square root of 27. Then we multiply by 2 because they're 2 triangles, we're just doing it in one step. Now for the area of the sectors. Call that area subsector. 2, again, because there's 2 of them, times 1/2. Theta, we just found that, it's pi over 3, times the radius, which is 6, squared. So that's going to be pi over 3 times 36. 36 over 3 is going to give us 12, so that's 12 pi. So, we found out the area of each of the 4 parts that compose the inside of it. So now let's just add them together. So the area is equal to 12 pi plus 6 times the square root of 27th. And that will be our final answer. I'm going to give you a moment to look at that in case you're wondering. Do this first, second, third, and then fourth. So there's 4 major steps to it. Thank you.